So we're going to do a little mini lesson on rational expressions and their graphs, and we're going to look specifically at the vertical asymptotes, the wholes, and the horizontal asymptotes. So I'm going to do kind of one of each one individually, and then we're going to see one example where they're all put together. So on this one here, we're going to talk about the vertical asymptotes. In vertical asymptotes, you basically take what's left in the denominator and you set it equal to 0. So on this one, we would take the denominator, which is x plus 6. You may have to factor at some point. I'm doing really simple examples. Set that equal to 0. So we should have a vertical asymptote at x equals -6. So let's go ahead and see that on a graph really quick. So I've got a graph here in Desmos. So there's the graph of it right there. And if I type in x equals -6, you see right in here that the vertical asymptote is definitely at x equals -6. Okay. So that's vertical asymptotes. Horizontal or wholes are what cancels. So let's take a look and see something cancel here. So we know that we would factor that numerator, and we would factor it into x plus 3 and x minus 3 because it's a difference of squares. And we're left with an x plus 3 in the denominator. So you'll notice that those cancel. Whatever cancels is a whole. So we would know that there's a whole. We take what canceled, set it equal to 0. So at x equals -3, there is a whole. And if you notice, when you simplify this, you get y equals x minus 3. So this is a picture of a line that should have a whole at -3. Unfortunately, when we look at the picture, okay, and I think I made my hole in the wrong spot. I'm going to turn off. So here's the picture of that graph, right? We have the same thing we had in the graph there. But you'll see at -3, no graphing utility is ever going to show a picture of the whole. So we can make our own whole if we need to. At least in Desmos we can. And it looks like it's at -3, -6. Okay, let's see if I can turn that on. So see, I can artificially place the hole there. So you kind of have to be smarter than the calculator or the technology and know that there's a hole and it cancels. All right, let's look at the next one. So the next one's a little bit more complicated. A horizontal asymptote, what you have to do is you have to look at the coefficients in front of the highest exponent. Okay. So we're looking at the, First we look at the exponents, and then we look at the coefficients in front of the exponent, okay? So this is actually wrong. So we need to fix your notes. I apologize. The numerator exponent is bigger. Oops, sorry. Go back to that. All right, so the numerator exponent is bigger. Cross that out, and you notice it's not the coefficient, it's the exponent. Then there is no asymptote. So if you notice here in this first one, the numerator's exponent is bigger than the denominator. So let's go look at a picture of that, and we're looking, remember, for a horizontal asymptote. All right, so I'm going to turn off my old stuff, turn on my new stuff. So that's the picture of that function there, and you'll notice there aren't any asymptotes horizontally or even vertically, but definitely no horizontal asymptotes. So when the numerator exponent is bigger, there are no horizontal asymptotes. When the denominators, let's look at this one. So cross this out. Again, it's not coefficient, it is exponent. When the denominator's exponent is bigger, okay, then we know that the asymptote is y equals 0. So if you notice down here, the denominator's exponent is 0, so my asymptote should be at y equals 0. A horizontal asymptote is always at a y equals. Yeah, this is kind of, I need to fix this too. I apologize. Look at exponents. And really if the numerator, so that's what goes into the chart. So look at the exponents. If the numerator exponent's bigger than the asymptote, has none. If the denominator exponent is bigger than the asymptote, is y equals 0. So let's look at a picture of that one. Okay. So if I look at that picture, so there's the picture of it, and if I go ahead and put the line y equals 0 in, you'll notice that it looks like it has kind of coming at it from both sides, but it looks like it's going to a horizontal asymptote there and over here at this end. So that's definitely a horizontal asymptote right there. All right, then let's look at that last one there. Oops, sorry. All right, so this one right here, if not the coefficients, if the exponents are equal, then you take, so notice my exponents are equal on this one, right? They're both ones. Oh, it's flipped into a pen thing. That's why, or a pointer. That's why it's doing that. All right, so if the exponents are equal, they're both ones, then what you do to find the horizontal asymptote is you take the numerator coefficient and divide by the denominator coefficient. I don't know why it keeps flipping. So all I'm going to do is I'm going to take these coefficients in front of those exponents, in front of those variables, and that's my horizontal asymptote. So let's try it out. We're going to put y equals 3/2 in on this one. All right, so I'm going to turn off my old ones. Here's my new graph. And I'm going to look at the horizontal asymptote. So I'm going to put in y equals 3/2. That's what we got. And you'll notice they're definitely both coming out to about 3/2 right there. All right, last little bit is we're going to find the holes, the horizontal asymptotes, and the vertical asymptotes on this problem here. Okay, so first thing I'm going to do is factor, which is what we've been working on a lot with the units this week. So I'm going to look for, I see a greatest common factor in the numerator. So I'm going to pull that out, and that leaves me with x squared minus 25. I'm going to leave my denominator alone for just a minute. And then I'm going to do the difference of squares factoring on the top because they're two square terms. So I've got 3. And we know that we take the square root of x squared and we get x. Square root of 25 and we get 5. And we make one a plus and one a minus. And then to do the denominator trinomial, we got to use a magic x. So I need two numbers that multiply to negative 15 and add to 2. And that would be 5 and negative 3. So we've got x plus 5 times x minus 3. So we're going to look at a bunch of things. First of all, what cancels? Cancels is the whole. So we're going to find our whole, and we're going to make that list at x plus 5 equals 0, or at x equals negative 5. There should be a whole. I'm going to rewrite it pretty. So we've got 3 times x minus 5 over x minus 3. Okay. Whatever's left in the denominator is the vertical asymptote. So I'm going to do my vertical asymptote next. I'm just abbreviating the words. So I'm going to take my x minus 3, set it equal to 0, and we get x equal to 3. And then the horizontal asymptote, I need to look at the coefficients in front. You don't really need to distribute that 3 in, but it also is 3x minus 15 over x minus 3. So if we look at notice the exponents are the same, right? So I look at the coefficients in front. So my horizontal asymptote, horizontal is always a y equals, is 3 over 1, or just 3. All right, so let's take a minute and look at those in the calculator. Sorry, it went all crazy. Okay, so I'm going to turn these guys off. I'm going to go back. I'm going to turn this on. So that's what the picture looks like. Okay. And we're going to look at the whole was at negative 5. So let's look at negative 5 and see where the whole should have been. So at negative 5, so right there on the graph, so it looks like maybe 3.5 maybe. So let's try that. So negative 5, 3.5. Let's see. Oh, we're not quite there yet. How about 3.8? We're closer with that. How about 3.75? We're much closer with that. And to artificially do it, I have to actually just push on this little guy here and change the style. Again, no hole is ever going to come up. All right, then we did the vertical asymptote. We said the vertical asymptote was at x equals 3. So let's try that. So x equals 3. So there's my vertical asymptote. And then the horizontal asymptote we said was at x equals 3 as well, I believe. Or sorry, not x equals, but y equals 3. There's my horizontal asymptote. Okay, so that takes care of this little lesson.